Okay, so how many of us have heard of the word volume before? How many of us actually know what it means? Nick, what do you think it means?
The area inside a three-dimensional shape.
So it's the area inside a 3D shape. Okay. Anyone else think they know what volume is? Dougie?
The space an object takes up.
Very good. I'm going to change this word from area to space. Because area is a unit of measurement, right? But area is two-dimensional. When we're talking about volume, we are, just like Dougie said, in a three-dimensional space, right? So there's going to be 3 dimensions there. Anything else about volume? Yeah, Cody?
Measured in liters.
Liters, okay. It's measured in liters. It's also measured in something called units to what power? Cubic units, very good. So instead of the second power, which was area, right? It's the third power. Why do you think it's now raised to the third power? What was that? It's 3-dimensional, very good, okay? Because it's 3D and our figures are going to be 3D, it's going to have a 3-dimensional unit. In other words, units cubed. What else do we know about volume? I have a question for you. How is it different from area? Hannah?
It can be like a 2D shape.
Yep.
Volume's always a 3D.
Very good. So area, guys, like look at the projector, right? If I were to draw a square here, is this 2D or 3D? 2D. Why is it 2D? Because it's flat. Very good. So if I were to find the space that this guy takes up, would I be finding area or volume? Area. Now, if I add dimensions, right, and I now create this into a 3D object, right? Now, if I were to find the space inside of this object, what would I be finding? The volume. So you've added a dimension once that figure starts to jump off the page, per se, okay? Once it gets added by that third dimension. Once it takes up an actual space other than just a flat surface, okay? All right. So today we're learning chapter 11, section 5. And guess what chapter 11, section 5 is all about? Volume, okay? And with a sprinkle of something called surface area, okay? So 3-dimensional objects, guys, not only, think of a can of soup, right? A can of soup, its volume, right? Or let's take this water bottle, for example, okay? This water bottle, how much water fits inside of it is considered its volume, okay? So if I were to fill it all the way, it would have complete volume inside the water bottle. Do you guys agree? Right now, I would say, what do you think? It's like a third of its volume? Would you say that's about a third of it? Yeah. Okay, so it's about a third of its volume. Surface area, okay, is the area around this water bottle. So the label all the way down here, this entire piece up top, the lid, the surface area is the surfaces all added together, but area, right? So if I were to wrap this like a Christmas gift, right? How much wrapping would I need to encompass the entire water bottle? That's the surface area, okay? The distance around your object. Volume is how much is inside, okay? So the more we do these problems, make sure you understand the difference between volume and surface area, okay? All right. So the first thing we're going to talk about is volume. And the volume of a solid is the number of cubic units contained in its interior. Also related to the amount of space that belongs inside the object, okay? Volume is inside the 3-dimensional figure. Volume is measured in cubic units. Guys, you're going to see me write it also as the units, and I'm just going to put a cubed symbol or the third power next to it, okay? And then there's something called Calaveri's principle. Calaveri's principle states that if two solids have the same height and the same cross-sectional area at every level, then they have the same volume, okay? That's a fancy way of saying that if the bases are the same, and the height is the same, then the volume is the same. Both. Okay? If the bases match and the heights match, then the volumes will match. Okay? Now, over here in the diagram in the picture, right? The first prism is like straight up and down. Do you guys agree? It's not slanted at all. But the second prism, do you see how it's slanted? They both have the same height. Because remember, the height is drawn perpendicular to the base, right? So going straight from the top, straight down. So technically, even though these two prisms, do you agree that they look significantly different from one another? They actually have the exact same volume because their heights are exactly the same, okay? The height of the prisms are exactly the same. They have the same volume. So we would say volume here equals the volume over here, okay? That's Calaveri's principle. So whatever your base is, as long as it's the same between the two prisms, as long as the heights are the same as well, the volumes will match each other, okay? Now, it does get a little bit confusing to conceptualize because you're like, how? That one's slanted. Shouldn't it be larger? But really all that matters, guys, is that the height of your figure matches. Go ahead.
Is that supposed to be like bases that are the same, like that are the same height, are the same volume?
Correct. Mm-hmm. So these two B's, right, for the purple cross sections are the exact same size, Daniel, in this figure, okay? All right. The volume of a prism, okay? We find the volume of a prism by using the formula capital B times H. This capital B, guys, is going to stand for the area of your base. And this H, you guys can probably already guess what that stands for. The height of what? Not of the base. Of the prism, okay? So the height of the prism is going to be it's not going to be a value that's part of your base, okay? So if you look at the figure on the left, what shape is this base? It's a rectangle. Do you guys agree? So we would say that this base would be equal to, what's the area formula for a rectangle? Base times height, or length times width, right? So if this is our length and this is our width, how many dimensions do I have in this prism? I have length, I have width, and I have what? Height. So there's 3 dimensions. I multiply all 3 of them, and I get the volume of this prism. Hence why volume is 3-dimensional.
The volume is the length.
Correct.
Interruption. Rocco and Luciana Falcone report to services. Rocco and Luciana Falcone report to services.
Yeah. So guys, check out the second one. Now, this one, maybe it wasn't said it explicitly, but what would you say the shape of this base is?
2-dimensional.
It is 2-dimensional, but what kind of shape is it? It's either a rectangle or what? Could potentially be a square, right? Don't they all look to be about the same? Let's say we knew it was a square, right? We had those congruence marks on it. What could you say about the area of this base? Our area of base would be what formula for the square? Length times width as well, right? But if they're all the same length, can't we just take one of the sides and square it? Okay? Now, your height is not this length over here. How do we find the height of the prism? Yeah, and what's so special about this H value? What's so special about it? Good, Sophia. The 90-degree angle that it creates with the bottom of the figure, okay? Remember, height is not going to be that slanted value. Height is going straight from the bottom of the figure all the way to the top. Must be perpendicular. Throw it away.
Is there, where it says volume equals pH, is there a number next to that, or is that just like a dot? Like under-
No, that's a comma.
Okay.
That's a comma, okay? What other questions do we have on this slide? No. Okay. A cylinder, okay? Now, a cylinder is not a polyhedron. We saw that yesterday, right? Why would this figure not be a polyhedron? Nick? It has curved edges, okay? So if it's curved, it's not a polyhedron. But it is still a prism, okay? It's a prism with a circular base, okay? So remember, prisms are just defined by objects that have both a base at the top and a base at the bottom. Pyramids, right, are those ones that don't have two bases, they only have one base. We're only dealing with prisms today. And a cylinder is a form of a prism, okay? Now, a right cylinder is the segment that joins the two centers of the circular bases is considered an altitude. So if this height, right, goes straight from the center of one of your circles down to the center of the bottom circle, then this is a right cylinder, okay? An example of not a right cylinder would be one that's kind of slanted. Do you guys see how this one is not like straight up and down? This would be an example of not a right cylinder, okay? So in this one, if you were to find the height, you would have to start at the center and draw a line down that's perpendicular with the base at the bottom, okay? This would be considered our height. Okay? Questions about the new shape that we've just learned, the right cylinder, or cylinders in general? Yeah, Hannah?
But there's no right angle on the right.
Yes, there is. So there's a right angle for both the heights.
Oh, it was kind of hard to see.
It was hard to
Red,
see, yeah.
good figuring.
You can draw it in there if you need to. Okay? Any other questions? Okay. Now, there's something called a lateral area of a cylinder. Okay? Now, this lateral area, how I like to teach it is I want you guys to draw a cylinder up at the top of your page. And someone give me a real life example of something that's in a cylindrical like casing. In real life, where do we see that shape in real life? What kind of jar? Jam jar? Okay, let's label this jam. Okay? And let's say this jam jar had a label that went all the way around the jar. Okay? The label that goes all the way around your jar is your lateral area. Okay? Now, the label for the jam jar, right? Does the label go on the top and the bottom of the jar most of the time? Does the label go completely around the jar? No, it only goes along the side, right? That is your lateral area. It is not the entire surface area of the entire jam jar, okay? Because it doesn't include the top of the jar, and I'll highlight this. It's excluding this top base, and it's excluding this bottom base. It's only the label that goes around the cylinder. Talk to me. What questions do we have about lateral area? Go ahead. Yeah, Anna.
Is it like does it matter if like the cylinder was like pointed or like more narrow and it was up top like?
No. So we're still going to use the same formula, okay? Actually, we won't see it where the two bases are different sizes, okay? That's going to be a different formula, all right? Good question, though. But we will see it where it's slanted, but it's the same size on the top and the bottom, okay? Yeah, Danny? Go ahead. Okay. Now, the total surface area, right, takes the lateral area, guys, which was 2 pi times the radius times the height, but it adds a piece to it. And that piece is 2 pi r squared. What does that look similar to? 2 pi r squared. That looks similar to the area of what? Of a circle. So check this out. It's the area of a circle, but it's a little bit different. Do you guys agree? How is it different?
Got the 2 in front of it.
It's multiplied by 2. Let's think how that applies to our cylinder, okay? So zoom out again. Look at the jam jar. If the lateral area was the label, what two pieces are not covered by the label? The top and the bottom. And the area of a circle, do you agree that the bases are both circles? So if the area of the top is pi r squared and the area of the bottom is pi r squared, wouldn't that explain why we're multiplying it by 2? Okay, so your total surface area for a cylinder is pi r squared times 2, so 2 pi r squared, plus the lateral area, which was 2 pi rh, okay? And you will see me write it as 2 times the area of the base, capital B, plus your lateral area. And this is surface area, SA, okay? You'll see me use this formula, okay? So we've learned 2 formulas so far, okay? We've learned the volume of a prism, okay, which was volume equals area of base times the height. And we've learned, 3, okay? Lateral area, which is 2 pi rh. And we've learned surface area, which is 2 pi r squared plus 2 pi rh. Okay. Is that what it is?
Plus.
2 pi r. The volume of a cylinder, okay? It's the same formula as the volume of a prism, which is the area of your base times your height. But for a cylinder, we know that the bases are what shapes? Circles. So we can replace that capital B with pi r squared because we know that the base has to be a circle. For a prism, we're going to see prisms with different shapes, right, as the bases. So those are left as capital B times H. But for a cylinder, it has to be a circle, so we're going to replace it with pi r squared. Okay? Now again, you may see a right cylinder like we see on the left, where your height is just the edge on the right-hand side. Or you also may see a slanted cylinder, where your H is going to be the perpendicular distance from the top base down to the bottom. Ronnie, you good? Okay. All right. Guys, that is. Let's do an example. So right now, we have a right cylinder, okay? And they probably should have given you a 90-degree angle there so that you know that the 7 is your height, okay? And we're asked to find the area of the base, capital B, okay? This capital B represents the area of the base, okay? What shape is the base for a cylinder? What shape is our base? Circle. Very good. So our base is a circle. So if we're finding the area of that circle, we need to use the area formula for a circle. What is the area formula for a circle? Pi r squared. So we're going to say the area of the base is pi r squared. Which of those segments is the radius, and how do you know?
5 centimeters.
5 centimeters. Why is it 5 centimeters?
Because it's perpendicular to the height.
What's that?
Because it's perpendicular.
Because it's perpendicular? The perpendicular we're going to use for the height. Why would that 5 centimeters be the radius? Yeah. Good. It's from the center to the edge of the circle. Remember what the definition of a radius is, okay? It's from the center of your circle to the edge. So this is definitely going to be 5 centimeters, so our radius is 5. Let's plug that in. So the area of our base, B, is going to be pi times 5 squared. Let's take out our calculators. And let's do pi times, what's 5 squared? 25. So let's do pi times 25. I got 78.5. What units does this get? What? Meter squared. Why? Or centimeters squared. Why? It's area. Very good. Okay, so we're going to put centimeters squared. What questions do we have on finding the base of this cylinder? The area of the base.
Wait,
Christian?
To use it, we have to multiply by 2.
Third interruption, Olivia Linares, Isabella Alejandra Ayala. Linares, Isabella Juliana.
But not until we find the surface area, we're going to double it, okay? The lateral area. Guys, you're going to have to go back for this formula. This is the first time we've used it. Who can tell me what the formula for lateral area is? No, it's not width times height. 2 pi RH. Go back, okay? No. Just lateral area. Lateral area, guys, remember, this LA stands for lateral area. And it's, if you want to write this down, put in quotations, it's your label, right? It's the distance, like, around your cylinder that doesn't include the top and the bottom, okay? And it's an area, right? It's how big would that label need to be to cover the entire cylinder minus the top and the bottom, okay? So, do we know the radius? It was 5, right? Do we know the height? It's 7. So we multiply all 4 of these. 2 times pi times 5 and then times 7. 219.9. So 219.9, and then we will, no, don't round. Remember, use the tens place if it doesn't say to round, okay? And then what units does this guy get? Centimeters squared or cubed? Squared. Why squared? It's still an area, okay? All right, so now it's asking us, TA stands for total area, or you'll see it a lot as surface area, okay? Let's label that. This is gonna be surface area. And surface area is your lateral area, what we found for the second part, plus how many bases do I have? 2 of them. So Christian, this is where we multiply that base value by 2. You got it? Okay, so my surface area, what was my LA value? 219.9 plus, and then I'm gonna do 2 times, what was my base value? 78.5. Okay, and this will give me 219.9 plus 2 times 78.5. 376.9. And this gets what units? Centimeters squared or cubed? Squared. It's still an area, so it's only going to be squared. All right, talk to me. Yeah, Cody. TA, total area. Okay.
So that's like the whole thing.
Yep. Okay. But it's the area, the outside. Very good. What would be the inside? Volume. Very good. We're about to calculate that. Okay. It's going to get different units though. Okay. It's going to get centimeters what? Cubed. Okay. Questions about area? Yeah.
Well, it's for volume.
It's for volume. Hold on. Questions about area? Okay. What's your volume question?
To do the width, do we have to add the radius?
No.
How do we do
The width.
Oh, no, we're doing
This is a cylinder, okay? So remember, the volume formula for a cylinder is the value of that base, the area of your base, times your height. And we already said our base was what shape? A circle. So the area of a circle is pi r squared times your height. So this is going to be pi times, we're going to replace the r with 5 because we knew our radius was 5. We're going to square it, and we're going to multiply it by the height, which was 7. So we're going to do pi times 25 times 7, 549.8. What units does this guy get? Centimeters cubed. Why cubed? It's a volume, okay? Ronnie, go ahead. Ronnie. Okay.
Well, I didn't know.
What questions do we have on example 1?
That
549.8. Guys, are we practicing with our calculators while I do these?
Yeah.
We should be, because I already can tell you that on the quiz, a lot of us got questions wrong. Not because we did any of the wrong work, because we were not proficient plugging in with our calculators. So get the practice now. Take out your calculators, go in your bag, take it out, and do these problems. Okay? Plug in these values. Yeah.
So for the last one, the volume,
Yep.
can't you just do
78.5 times 7. Yes. Let's do it. 78.5 times 7, 549.5, right? Yeah. So it's just slightly off. It's about 0.3 off. Okay?
not the whole thing?
Correct. Go ahead, Zach. Wait, no. Moving on. Example 2. Find the volume of the puzzle piece shown in cubic units. Is this shape a prism? No. Could we divide it somehow so it's maybe 2 prisms? Okay. How would you like to divide it? Straight up and down?
Yeah.
You sure?
Yes. No, but cut it
I mean,
you can cut it across from the top.
I personally would just slice off this guy. Why would I do that?
It'll give you
It makes a super small guy and then a larger piece, right? Can you do this problem by slicing it down this way? For sure, you can do it either way, okay? But you've got to make 2 prisms now out of a single figure, okay? And we're going to call this prism, prism A, and we'll call this prism, prism B. All right, let's deal with prism A first. So prism A, we're finding the volume of it, okay? So we're going to say the volume of prism A, VA, for volume of A, is going to be the base area times the height. All right. Now, let's zoom in on the base. Do you guys agree that this would be the base of my prism? And then this would be my height? Okay. What shape is the base? It's a square. How do you know it's a square, Zach? How do you know that all the sides are congruent? Very good. Guys, look down here. Do you see how it's 1 unit thick, the prism? That 1 unit can be copied over here. So we now have 1 by 1 unit for the base. So if the area of the square, so the base is a square. So the area would be length times width, or just length squared. In other words, we're going to take that 1 and we're going to square it. What's 1 squared, guys? So it's just 1. So the dimensions of my base gave me an area of 1. So we're going to say the volume of the figure A is 1. What's the height? Also 1, okay? The height is also 1. So we're going to do 1 times 1, which is 1 unit cubed. So that 1 block up at the top is exactly 1 cubic unit, which makes sense because all of its dimensions were 1. Do you guys agree?
Yes.
Okay. So now the bottom prism, right? I want you to try to guess how many of these single blocks would fit in the prism on the bottom. 2? 1, 2. That would take up the entire prism. 6. I would say about 6 of them. Do you guys agree? So let's see if we get 6 when we calculate the volume of the prism B, okay? So let's do volume of prism B it's also going to be the area of the base times the height. Now, the base for this prism is not a square. What is the base for this prism, guys? It's a rectangle. Very good. And it's 3 units by 1 unit. So the area of the base is the area of a rectangle, which would be length times width. In this case, it's going to be 3 times 1, which is just 3. So our B value is going to be 3. We're going to use that here. So the volume of the base, or the volume of figure B, is going to be 3 times the height. What is the height, though? It's 2 units, okay? Our height is 2 units. So we're going to do 3 times 2, which gives me 6 units cubed. Did we anticipate 6 of those cubes fitting in? Perfect. Okay?
You can actually duplicate the cube at the top and then just slide it down and you get 6. I get it.
So really quickly, guys, what is the volume of the whole puzzle piece? How is it 7? You add them together. So we're going to take the volume of A plus the volume of B, which gives me 6 plus 7. Nope, 1 plus 6, which gives me 7 units cubed. And that is the volume of the entire puzzle piece. What questions do we have on this example? Now, I know a lot of you guys are like, well, why can't we just do length times width times height, okay, for the prisms, right? And that's only true if it's a rectangular or a square prism, okay? We're going to see other prisms, like triangular prisms, okay, pentagonal prisms, okay? So you're going to have to know, you just find the area of the base and multiply it by the height. That's a more surefire way to get you the right answer versus just length times width times height, because not all of them are going to be the same prism, okay? All right, let's check out the next example. Find the volume of a square prism that has a base edge length of 5 feet and a height of 12 feet. Were we given a picture? What do you think I'm going to do? Draw a picture. So draw the best square you can, and draw that same square a little bit further down. Oof, this is not going out well. Square, square. There we go. Okay, so the shape of my base is what shape? A square, okay? So this is a square base. What are the length of its sides? What are the length of its sides? We don't know? They're 5. Well, how did you know it was 5? Very good. Its base edge length is 5 units, okay? So we're going to say it's 5 feet by 5 feet, okay? And it's a square, so I know each of those sides are congruent, right? The height of the prism is 12 feet. So if we were to draw a perpendicular segment down to the base, it would be 12 feet. And this represents my height. So remember the volume formula for a prism. It's the area of the base times the height. How do I find the area of a square base? Okay, what's the length? 5, and the width? 5. So it's 5 by 5, so we multiply 5 times 5. We get that our base is 25 feet squared. But that's only the area. What do I need to multiply that to get the volume? By 12, very good. So our volume is going to be the area of the base, which is 25, times 12. And when you multiply 25 times 12, you get 300. So the volume is 300 feet, what? Cubed. Why cubed? Because it's volume. All right, one more and we'll be done. Okay. The volume of a right cylinder is 684 pi cubic inches and the height is 18 inches. Find the radius. No picture given. Let's draw one. So it's a cylinder. It's a right cylinder, so it's going straight up and down. It has a height, so from top to bottom, of 18 inches. And the volume of the whole thing is 684 pi. Let's use our formula for the volume of a cylinder. The volume of a cylinder is the area of the base times the height. My base is a circle. So my area formula for the base, my B value, is going to be pi r squared. Because my base is a circle. So I'm going to say my volume is pi r squared times the height. I know the height, I know the volume, so I'm just going to plug those in. The volume is 684 pi. The height is 18 inches. So 684 pi equals pi times the radius squared times the height, which is 18. I'm solving for the radius. I'm going to divide by pi and 18 so that these both cancel out. Divide by pi and 18. The pi's will cancel out. So I'm going to get 684 divided by 18, which is 38, equals r squared. And then I just take the square root of both sides. So we take the square root of 38, and we get 6.2. So our radius is 6.2. What units does it get, though? Inches. Squared or cubed? Squared? Cubed? Neither. What is the radius? Is it a length or an area? It's a length, okay? We're going to stop here. Guys, turn in your notes before you leave.